Okay, now we're going to start looking at a very important principle that we need to start using in Module 3, and that's called the unit circle in trigonometry. The unit circle is a very important and useful tool. So I want to take a few minutes and quickly sort of summarize what the unit circle is and then how we use it. So we start out with our normal sort of XY graph. And now I'm going to draw a circle with the center at the origin, except the circle is going to have a radius of 1. So in other words, on the x-axis, if I put 1 here, and on the y-axis 1 is up here, and over here is -1, and down here is -1. Then I'm going to try and draw a circle. It may not look, it's hard to draw a nice perfect circle, but all right, not perfect, but hopefully close. So I've now drawn this circle on my graph where the radius is 1. In other words, the distance from the origin to any point on this circle, that distance is 1. Okay, and that's why we call it a unit circle. When you use the word unit in math, usually the word unit means 1. So this is a circle of radius 1. All right, so how does this relate to trig? Well, what I'm going to do is I'm going to choose a point on this circle. And actually, I'm going to choose a point right here. Now, this point, anytime we have a point on a graph, we have the value of x and the value of y, right? So here's the value of x, and here's the value of y, right? It's a point on the graph. It happens to also be on the circle, but it just has an x and a y. But what I'm going to do to this point, I'm going to take this point and now use this point to create an angle, right? So I'm just going to go, anytime we look at angles on our XY graph, the initial side is the x-axis, and this will be what we call the terminal side. So here I've created an angle theta. All right, we've done that before. Now what's interesting is I'm going to choose a certain point here, x and y, but I actually know what the x and the y is. As it turns out, for this point here, the x is 4/5 and the y is 3/5, which means this x value is like 4/5, or you could call it 0.8 as a decimal, and the y here is like 3/5 or 0.6. So I could just say that point right there is 4/5, and this right here is 3/5. Right? So this is 4/5 on the x-axis. This is 3/5 up here. So here's a point, 4/5, 3/5. Let's think back now to this angle. Let's look and think that we have like a right triangle right here. Here's one side, this is the hypotenuse, here's the other side. And let's just go see now, let's figure out what the trig functions would be of this angle here. And let's look up, we can do them all. Of course, the main ones are sine and cosine. So we learned when you have a right triangle, we can figure out the trig function. Sine is so, right? So katoa so, opposite over hypotenuse. So in this case, if my angles here are the opposite, is this side right here. This distance here is really y, which for this point, what's y? Y is 3/5. So 3/5 opposite over hypotenuse. What's the length or the distance of the hypotenuse? Well, we said this is a unit circle, which means a radius of 1. The hypotenuse is 1. Distance from here to here is 1, because we drew it that way. So really it's 3/5 over 1. So the sine of that angle is 3/5. Sort of interesting, the sine of the angle is actually the same as the y value of this point. It's interesting. Let's see about cosine. So cosine of this angle, so ca adjacent over hypotenuse. Adjacent is going to be this distance right here. Of course, that distance is like x, which in this case it's 4/5. So from here to here is the distance of 4/5. Adjacent over hypotenuse, once again, what's the hypotenuse of this triangle? It's 1. So the cosine is 4/5. And what's interesting now is, once again, looking at this point, the x and the y of this point is 4/5 is the x, 3/5 is the y. I took that point and I sort of created a triangle from the origin to that point. We called that theta. Then I decided to go get the trig functions for this angle here. And lo and behold, the sine of that angle is 3/5, which is the same as the y. And the cosine of the angle is 4/5, which is the same as the x. So this is an example of really the key idea of the unit circle. And here it is. Anytime you use a unit circle and you're trying to find the trig functions of an angle for the unit circle, if I know the x and y of my point on the unit circle, in other words, here's my point right here that I'm using to create my angle, but I know the x and y of this point, 4/5, 3/5. Once I know the x and the y of the point, I automatically know the cosine and the sine. Because the cosine of this angle is always the x value of this point. And the sine of this angle is always the y value of this point. So the neat thing, or the beauty of the unit circle, is anytime I have a point on the unit circle and it creates an angle, as long as I know the x of that point and the y of that point, I automatically already know, without doing anything, I know the cosine and the sine of the angle. For example, let's do another one. Maybe I'll try and do it on the same. Here's another point. I'm going to choose this point right here. I did this beforehand, so it turns out this point here, the x is 2/5, which is like, 0.4, so that's about right. And the y of this point, the value of y, turns out it's square root of 21 over 5. So here's another point on this unit circle. If I decide to go ahead and use this point to create an angle, I'll call this angle theta 1. And I decide to go get the trig functions of this angle theta 1, you know what? because I know the x and the y of this point here, I don't have to do anything. The sine is always the y value. Maybe I can write it here. The sine is always the y value. The cosine of the angle is always the x value. So if I want the sine of this angle, the sine's the y value. The sine is square root of 21 over 5. The cosine of that angle is the x value, which is 2/5. So I've already determined the two main trig functions for this angle. Now you notice these two examples both occur in what we call quadrant 1. But the nice thing is, and the very powerful thing about using the unit circle, I can choose any point anywhere around this circle, and this same rule applies. If I know the value of x and the value of y, then I automatically know the cosine and sine. So for instance, let's go choose a point in maybe quadrant 3. This is quadrant 3. So I'm going to choose, how about I just for fun, let me just choose I'll go, right here is like 1/2. It's actually negative 1/2 in the x. I'll choose this point. So I know the x is negative 1/2. Now I'm going to figure out the y. Now you don't necessarily know how to do this, but I'm going to take a minute and I'm going to figure out the y. And I have to do a quick little calculation here, which I'm not, it's using the Pythagorean formula, but I don't want to explain it to get too complicated. So this is 1 minus, this is 3/4. So it turns out for this point here, if the x value is negative 1/2, the y value ends up being negative square root of 3 over 2. So the key thing is, don't worry about this. The key thing is here's another point on my unit circle. And I've determined the x value is negative 1/2 and the y value is negative square root of 3 over 2. And now I want to know the trig functions of this angle. Well, this angle here, it starts here and goes all the way over here. Right? It's this angle. So now I say, well, what's the sine of this angle? Okay, whenever you have a unit circle, which we do, the sine is always the y value of the point. What's the cosine of this angle? The cosine is always the x value of the point. So what they're going to do in the homework and on the quiz, they're going to give you a point on the unit circle, and they're going to say, find all the trig functions. Well, the first thing you're going to do is, because the x is the cosine and the sine is y, you can first get the sine and cosine. Now let me do this problem here. Once you have the sine and cosine, you can figure out all the rest of the trig functions once you know the sine and cosine. Because remember, so say I need that, say for this angle theta 2, I'm going to get all the trig functions. I've already gotten the sine and the cosine. The tangent, you remember, one way we can figure out the tangent, it's sine divided by cosine. So here's the sine. I already figured out the sine is negative square root 3 over 2. Cosine is negative 1/2. When you simplify this complex fraction, tangent is square root of 3. Cotangent we can do next. Well, cotangent's easy because cotangent is just the reciprocal, the inverse of the tangent. Right away I can say cotangent is 1 over square root of 3. How about the secant of theta 2? Well, I know the secant is a reciprocal, or I have to just flip the cosine. Remember, secant is with cosine. I know my cosine was negative 1/2. If I flip it, it's just negative 2. And then finally, the cosecant. Cosecant's where cosecant is paired up with the sine. So if you flip the sine, negative 2 over square root of 3. So in summary, if you have a point on the unit circle, and you know the x and the y of that point, and then you use that point to create an angle, right away, because you know the x and y of that point, you automatically know the sine and the cosine of that angle. Let me do one more example, just so you really get it down. Maybe I'll try and draw another unit circle. So this is x and y. So this right here, this point is like 1, 0. This up here, this point is like 0, 1. This here is negative 1, 0. This point here is 0, negative 1, right? Just the x and the y. So say I'm going to, let me try and come up with another point, maybe in quadrant 4. How about I'll go like, maybe like on the x-axis, 1/10. So very short distance, 0.1. So this point right here, I know the x is 1/10. Now I'm going to go, once again, do my little calculation to figure out the y. You won't have to do this in the homework, but this is going to be a little bit crazy, because it's going to be 1 minus 1 over 100. It's like square root of 99 over 10. And I don't think I could, 9. 3 square root of 11 over 10. Wow, that's crazy. So the y value of this point is pretty ugly. 3 square root of 11 over 10. But of course, it's negative, since the y is negative. So here's the point. Now, I'm going to create an angle. So I've got this point here. The x is 1/10, the y is negative 3 squared 11 over 10. Now I'm going to look at the angle here, And right away, I can say the sine of that angle is my value of y, 3 square root of 11 over 10. And the value of the cosine of that angle is 1/10. If I want the tangent of that angle, sine over cosine, negative 3 square root of 11 over 10 over 1/10. Negative 3 square root of 11 over 10. Oops. Negative 3 square root of 11. Cotangent. Flip the tangent. Negative 1 over 3 square root of 11. Secant. Flip the cosine. It's going to be 10. Cosecant. Flip the sine. Negative 10 over 3 square root of 11. And there I have now all 6 trig functions for the angle that's created by using this point here, 1/10, negative 3 square 11 over 10. So in the homework, they're going to just give you a point on the unit circle, and they're going to say find all these. It's very simple, right? The cosine's the x value, the sine's the y value, and you're on your way. So that's the principle of the unit circle. Now let me explain to you how we use it all the time in trig, because normally we don't just choose random angles. Remember 1 or 2 lessons ago I said we have special angles, and angles we use over and over again when we work problems. And I said the special angles were 30 degrees, 45 degrees, and 60 degrees. Actually, I should add 0 degrees, 30, 45 degrees, 60, and then 90, right? Matter of fact, if you look at, maybe I'll draw a unit circle again. You know, right here is 0 degrees. Halfway up is 45. All the way up here is 90 degrees. Then 30 degrees is right here, and 60 is right here. So here are the special angles. Although we actually need to know them in radians. In radians, it'd be 0. 30 degrees ends up being pi over 6. 45 degrees is pi over 4, 60 degrees is pi over 3, and 90 degrees is pi over 2. So I could write them inside here: 0 radians, pi over 6, pi over 4, pi over 3, pi over 2. So you'll have to know both. Matter of fact, for the next little bit, we're probably going to use radians a lot more than we use degrees. So you have to understand these. So this is a unit circle. So I'm going to call this point 1, 0. And this point here is 0, 1. Do you remember? Well, here's what I'm going to do. Just to give myself some more room, I'm going to draw another unit circle. And for these special angles, right, I've got 45 degree, 30 degree, 60 degree. For each of these points, I'm going to show you what the x and the y is. X and the y for this one, 1, 0. Turns out for this angle here, which I'm going to call either pi over 6 or 30 degrees. You know what the x and the y is of this point here? The x is square root of 3 over 2. And the y is 1/2. If I go this next point, That one's pi over 4 or 45 degrees. This point here, the x is square root of 2 over 2, and the y is square root of 2 over 2. Actually, they're the same exact. X and y are the same. Finally, up here, this is pi over 3 or 60 degrees. The x here is 1/2. The y is square root of 3 over 2. What's interesting is, look at my 30 degree. Square root of 3 over 2, 1/2. You go up to 60 degree, 1/2 square root of 3 over 2. It's just a flip. The x becomes the y becomes the x. And then we get here to the top, of course, and we'll call this 90 degrees or pi over 2. Of course, this is 0 degrees and 0. All right, so now, based upon this, how about I go just find a couple of trig functions for this? In other words, what if I say, what is the sine of pi over 4? This is a unit circle. So what I do is I go find my pi over 4 angle, which is right here. Since I want the sine, what do? I simply grab the y value of that point, and I know the sine. How about I want to find the cosine of a 30 degree angle? I'm going to use my unit circle. I'm going to go find my 30 degree angle point. This point here is what makes up a 30 degree angle. If I go from the center to this point, that's a 30 degree angle. But I'm wanting the cosine. Since this is a unit circle, the cosine is the x value. So I know right away the cosine of 30 degrees is square root of 3 over 2. What if I want the tangent of 45 degrees? Well, the first thing I'm going to do is I'm not going to find the tangent straight away. I'm going to break it up into sine and cosine. So I know tangent is always sine over cosine. So the tangent of 45 degrees is really sine of 45 degrees over cosine of 45 degrees. Let me go and, so now what's the sine of 45 degrees? I go to my 45 degree angle point, and the sine is the y value, square root of 2 over 2. Now I go get the cosine of 45 degrees. I go to my 45 degree angle point. The cosine is the x value. It's square root of 2 over 2. Now if I simplify this, it looks like the top and the bottom are the same. Therefore, the tangent of a 45 degree angle equals 1. How about cosine of pi over 2? Well, I go find the point that gives me a pi over 2 angle, and since I want the cosine, I go look for the x value. So, pi over 2 is right here. The x value is 0. Cosine of pi over 2 is 0. We'll go back to a degree. How about the sine of 90 degrees? If I go to the point that gives me a 90 degree angle, which is right here, the sine is the y value of that point, which is 1. Sine of 90 degrees is 1. So here's what you're going to have to do. I'll make another video, but let me just show you. Here's a diagram of the full unit circle. It might look very confusing at first. Matter of fact, let me make the screen so I can fit it all in there. Here is what we call the unit circle. And actually, I'm just going to stop now and come back in the next lecture, and we'll take a very close look at this chart. It looks amazingly confusing probably, but once we talk about it, you figure out it's not really that hard. So let me stop now, and we'll pick up on the unit circle in the next lecture.